Okay, in our lesson today, we're going to combine the three laws on Boyle's law, Charles' law, and Gay-Lussac's law to form one gas law, which we call combined gas law. So from previous lessons, we discussed about Boyle's law, which states the relationship between pressure and volume, which is inversely proportional. So we can state that as P1. So P1, V1 equals P2 and V2. And for Charles' law, we can state that as V1 over T1 equals V2 over T2. And for Gay-Lussac's law, we have P1 over T1 equals P2 over T2. So we're going to put this all together into one gas law, which we call it the combined gas law. Okay, so put all these two together to make the combined gas law, which states the relationship between pressure, volume, and temperature, which is equal to P1 V1 over T1 equals P2 V2 over T2. So the constant here is the amount of gas. Okay, so I can put here the constant is the amount of gas, which is also we call it as the number of moles. So if we're going to manipulate the formula, if you are looking for P1, that's gonna be, remember that this is cross multiply. So P1 V1 times T2, and then P2 V2 times T1. So let me put that like this. So P1 V1 times T2, that is cross multiply, and then cross multiply this, so equals P2 V2 and T1. So for example, you're looking for P1, your formula will be P2 V2 T1 divided by V1 and T2. So we have V1 and T2. And if unknown is V1, then the same thing, you're going to multiply P2 V2 T1 divided by P1 and T2. And if you're looking for T2, your formula will be P2 V2 times T1 over P1 times V1. And if you're looking for final pressure, it's going to be P1 V1 T2 divided by V2 and T1. If you're looking for volume 2 or final volume, that's P1 times V1 times T2 divided by P2 and T1. And then if you're looking for T1, that's going to be P1 V1 times T2 divided by P2 and V2. So these are the different formulas that you're going to use when looking for each of these unknown variables. Okay, let us have one example here. A sample of sulfur dioxide occupies a volume of 652 ml at 40 degrees Celsius and 720 millimeters of mercury. What volume will the sulfur dioxide occupy at STP? So first is you identify the given. So let me highlight here what are given. So we have here the volume, which is 652 ml. And then, of course, this is the temperature and this is the pressure. So what volume will the sulfur dioxide occupy at STP? Remember when we said STP, that stands for standard temperature and pressure. So let me just put here at STP, that is standard temperature and pressure. And you know that standard temperature is equal to 273 Kelvin. Remember, when we're talking about temperature, we always use the Kelvin temperature. If the temperature is in degrees Celsius, you have to make sure you add 273 Kelvin. And then the pressure is 1 atm, so it depends on what unit. So if the unit is millimeters of mercury, that is equivalent to 760 millimeters of mercury. So this is the standard pressure at millimeters of mercury. But when we're talking about atm or atmosphere, that would be equal to 1 atm. Okay, so 1 atm equals 760 millimeters of mercury. Okay, so let's try to identify the given. So we have here V1, which is initial volume, that's 652 ml. And then of course we have our T1, which is 40 degrees Celsius. Remember to convert degrees Celsius into Kelvin by adding 273. And then we have also your initial pressure, which is 720 millimeters of mercury. Okay, let's try to use your calculator. That's 40 plus 273 equals 313 K Kelvin. And of course, our V2, which is, that's what we're looking for. It says here, what volume will the sulfur dioxide occupy at STP? So that means our our final temperature, I should say, is the standard, which is 273 K. And then our volume, since our pressure, I should say, the pressure is in millimeters of mercury. So we will use the 760 millimeters of mercury as our standard pressure, mmHg. Okay, so we can use the formula now. We're looking for V2. So if V2 is unknown, then we can use the formula for combined gas law here. So P1 V1 times T2. So we have P1 V1 times T2 divided by P2 and T1. So that's going to be P2 times T1. So you can plug in the given to the formula. So we have, okay, so we can plug in now. So that's 720 millimeters of mercury. That's our P1. And then multiply by V1, which is 652 ml, times T2, which is 273 K, and then divided by P2, which is 760 millimeters of mercury, times your T1, which is 313 K. So you have to make sure you cancel out the units. So millimeters of mercury, and then of course Kelvin is cancelled. And then we get the milliliter as our desired unit. So all you have to do is multiply 720 times 652 and then multiply by 273, and then we will get there 128,000 million. So 157 120 divided by 760 times 313. So we have 760 times 313. That would give you 237,880. And then you're going to divide this two right here. So 128,157,120 divided by 237,880, and then you will get 539. Let's say 539 ml. Okay, so this should be your final volume. So final volume right here is 539 ml. Okay, let us proceed to our second problem. A gas takes up a volume of 17 liters, has a pressure of 2.3 atm, and a temperature of 299 K. If I raise the temperature to 350 K and lower the pressure to 1.5 atm, what is the new volume of the gas? All right, so we're going to identify the given. We have P1, V1, and then T1. And we have P2, V2, and then RT2. So P1, which is 2.3 atm, and then V1 is 17 liters, and then of course the temperature is already in Kelvin, so make sure you put that as 299 K. You don't have to add 273 because it's already in Kelvin. And then if I raise the temperature to 350 K, so you raise the temperature to 250 K and lower the pressure to 1.5 atmosphere, what is the new volume? So we're going to find the new volume of the gas. If we're looking for the new volume, our formula will be P1 V1 times T2 divided by P2 times T1. So that's going to be P2 times T1. So we can plug in the given, which is P1 V1 times T2. So our P1 is 2.3 atm times V1, which is 17 liters, times T2, which is 350 K, then divided by P2, which is 1.5 atm, times RT1, which is 299 K. So make sure to cancel out the unit that are not required. Okay, so and then we have the V2. So we're going to multiply. We have let's use our calculator here. So 2.3 times 17 times 350, so we get 13,685. Then divided by 1.5 times 299, so 1.5 times 299, you will get 448.5. 448.5. And then we're going to divide this two. So that's 13,685 divided by 448.5. Then we'll get 31. So you can have you have 31 liter. So that's gonna be our new volume. Okay. So our new volume here is 31 liters. Okay, let us have one more problem here. A gas that has a volume of 28 liters, a temperature of 45 degrees Celsius, and an unknown pressure has a volume increased to 34 liters and temperature decreased to 35 degrees Celsius. If I measure the pressure after the change to be 2 atm, what was the original pressure of the gas? So we can write this as P1 equals unknown, because it says here what was the original pressure. So that means original pressure is your P1 if the pressure was changed to 2 atm. So that means 2 atm is your pressure. And then your initial volume is 28 liters. And then your final volume is 34 liters. And of course, your initial temperature is 45 degrees Celsius. Remember to convert this into Kelvin by adding 273. And also your T2 equals 35 degrees Celsius plus 273. Okay, let's calculate that. So 45 plus 273. Okay, that would give you 318 Kelvin. And how about this? 35 plus 273, that's gonna give you 308 Kelvin. Okay, so what you're looking for here is P1. Okay, so our formula will be P1 equals, remember P1 is right here, P1 V1 times T2, and then P2 V2 times T1. So P2 V2 times T1 divided by V1 times T2. Okay. So our P2 is 2.0 atm times V2, which is 34 liter, times T1, which is 318 K, divided by V1, which is 28 liter, times T2, which is 308 K. All right. So 2 atmosphere times 34 liters times 318. That would give you 21,624 divided by 28 times 308. So we have 28 times 308. That gives you 8,624. That's correct? Okay. So you're going to divide these two numbers, 21,624 divided by 8,624, and that would give you 2.5. So we have 2.5 atm. Okay, make sure you cancel out the units that are not required. So this is gonna be your initial pressure, which is 2.5. So your initial pressure is 2.5 atm. So that's it. That's our lesson for today about combined gas laws. So if you have any questions, I'm always available in my email, and you can always message me, or you can always post your questions in the Google Classroom. Thank you, and I look forward to hearing from you.